Lesson 11.8 is finding perimeter of regular polygons. Remember, a polygon is a shape that has any number of sides. And in this case, they're talking about a regular nonagon, which if you count it up has 9 sides. Sorry, a piece of orange on my hand. Find its perimeter. So remember, perimeter is going to be adding up all the sides, or if we could find one of the side, take it times 9, so that it could be a little faster. So what they're giving us right now is a radius. So believe it or not, besides a circle, other shapes can have technically a radius. If it's from the center to one of these vertices, or these kind of edges here, where it meets, or the two sides meet, I should say. But that's called a vertice. And they tell me this is 8. So what I would like to do is go ahead and make a triangle. But I can't find out what this side is yet, because I don't have a right triangle. But if I were to drop down an altitude, that makes a 90. And so I could really work in this little triangle. Okay, so what I've got here is, let's figure out if I were to make triangles everywhere, right, from each vertice to the center point. We'll have our 9. Think about all the way around here. The whole circle is 360 degrees. But let's divide that by 9. So 36 divided by 9 is 4. That'd be 40 degrees. 40 degrees is in this whole triangle here. Look like this. But I want to cut that in half, because that's what an altitude does, is it cuts this into 2 congruent triangles. This is now 20 degrees right here. So I'm going to use a trig function to figure out what this is. And so from my 20 degrees, I have its opposite leg, and then this would be the hypotenuse. That would be using sine. So sine of 20 degrees would be x over 8. Multiply by 8. Remember, you got to be in the right mode. And I get about 2.736. But that was only for half of this side. So I would have to take that times 2 to get 5.47-ish. And so that's what this side would be. But then for the perimeter, I want to take that times the 9 sides. And I get 49.3. So I would keep that same decimal in your calculator so that you get precisely what they're wanting. And I guess that doesn't have a label. So 49.3 is our answer. Then there's this other thing that's called an apothem. An apothem is still from a center point, but then it's to the middle of this side. So it's kind of opposite of what we had. It's like our altitude. So I'm going to go ahead and create a triangle here, right triangle. And then we're going to do the same thing of figure out what this degree would be. So think about all the way around here would be 360. We want to divide by a dodecagon, should be, I think, 12 sides. You could count them up if you wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. 36 divided by 12 would be 3, so that'd be 30 degrees. In the triangle, be careful, in the triangle is 30 degrees. Because you cut this into 12 triangles. Then you want to cut that in half, this would be 15 degrees. You could also think, how many little right triangles are there going to be? Well, if there's 12 big triangles, divide that by 2, or have 2 in each one, that'd be 24. You could take 360 divided by 24, and that would automatically get you 15 degrees. Okay, and then in there, I'll do the same thing where I'm finding this side. So from here, I've got its opposite, and then this time I have the adjacent. I do not have the hypotenuse. So opposite and adjacent is tangent of 15 degrees would be x over 20. Multiply by 20. And then that would be about 5.36. Okay, and then also, I'm still finding perimeter. So then that would be this. but I'd want to double it to get here. And then since there's 12 sides, I'm going to take that times 12. And I'd get 128.6. for its perimeter.